Today we are going to talk about the law of sines. What the law of sines does, it helps you find a missing side or a missing angle. Now if you saw this triangle over here on the left and I said find that side, you would notice it's a right triangle, so you could use the Pythagorean theorem. However, look at this triangle over here. Oh, it got cut off in our little thing. Well, that triangle is not a right triangle. It looks very similar to this, except it's not a right triangle, and I ask you to find the third side. Well, you can't find the third side using the Pythagorean theorem. What you could use is the law of sines instead. Now, if the problem has two sides and two angles, you will use the law of sines. And today we're going to use the law of sines all day, and I'll point out how we see the two sides and two angles. The formula for the law of sines is on the right-hand side here. It doesn't matter which way you write it. Also, it's given to you on the Regents exam as the second set here. One thing to realize is that you only use two proportions at once. You will never use all three at once. Little letters represent sides. Capital letters represent angles. And the side is across from the angle when we label our triangles. Let's move. Alright, so it says, in triangle ABC, side A is 8, angle A is 30 degrees, C is 55, angle C there. Find side C to the nearest tenth of an integer. And it did not really give us much room for this because it looks like, I know yours looks better than mine. However, my wording on my sheet here has kind of two problems in one. So let's work on this green triangle first, and then we'll work on triangle DEF afterwards. So for the green triangle, you should notice this problem talks about two sides and two angles. So I know I would use law of sines. The setup for law of sines, I don't care about the formula too much. I just need to use the side and the angle across from it equal to the side and the angle, sine of the angle across from it. So this particular setup will be 8 over sine 30 equals side C over sine 55. Then we have to solve for C. The way we solve for C is by cross multiplication. So cross multiplying would give me 8 sine 55 equals C sine 30. And to solve for C, we divide by sine 30. In your calculator, you make sure it's in degrees, and you just type the whole left-hand side in your calculator. If it opens a parenthesis on the 55, just close the parenthesis before you hit divide sine 30. You will end up getting C equals nearest tenth, 13.1. And that's it. That's your law of sines. Now I'm also going to do this triangle DEF here. And I know you have the information already. It says sine of F is 1/5. Sine of D is 2/5. Side F is 24. We want to find side D, it does ask for. This problem does talk about two sides and two angles, so we'll set it up. We'll start with I'm going to do it over here in red, 24 over sine of the angle across from it. Well, that's sine of F. It tells you sine of F is 1/5, so you just put a 1/5 down there. Equals the other side, D, sine of D. Sine of D, it says, is 2/5. Now to solve this, we cross multiply. So we'll get 1/5 D equals 9.6. And then divide by 1/5. 9.6 divided by 1/5 is 48. So that should take care of the front of your notes. On the back of your notes, it says in triangle ABC, it doesn't give us a picture, so let's draw ourselves a picture. A, B, C. Little c is 12, that means the side across from angle C. Measure of angle C is 2 pi over 3. Measure of angle B is pi over 6. We want to find the exact value of B, side B, in simplest form. Well, two sides, two angles, let's use our law of sines. So it's going to be 12 over sine 2 pi over 3 is equal to B over sine pi over 6. Cross multiply. To solve for B, we divide by sine 2 pi over 3. Go. Sorry. Now you could type this all at once in your calculator. Most of the time you would be fine. But this one does say find the exact value. So let's do each piece separately. Calculator in radians because you have pi values. You'll have 12. And then if you type sine pi over 6 in your calculator, it gives you 1/2. And if you type sine 2 pi over 3 in your calculator, it's 0.8660. But we know that that's radical 3 over 2. 12 times 1/2 is 6, and this is still radical 3 over 2. Let's do a state change flip, so it's going to be 6 times 2 over radical 3, which is 12 over radical 3, which when we rationalize is 12 radical 3 over 3, and we reduce, it's 4 radical 3. So 4 radical 3 is our answer there. Let's set up this triangle. You guys will do this one on your own after we do the setup. It says in triangle PQR, angle P is 125, angle Q is 14, side P is 122. And it says find R to the nearest integer. In order to find R, you do need the angle across from R. But we can easily find that before we start. The way we find that is just knowing that in a triangle, the angles add up to 180 degrees. So you'll take 180 and subtract 125 and 14 from it to get 41. Now you have the setup. You guys finish that one later for the do now. I'll set this one up as well, and you guys will finish this one. The length of one side of the equal sides of an isosceles triangle is 25.8. Well, that means the other one is also 25.8. Each base angle measures 53. Find the measure of the base of the triangle to the nearest tenth. Alright, so that means we're looking for that side. And in order to get that side, we need the angle across from it. To get the angle across from it, it's just like last time. 180 minus 53 and 53 will give you 74. Okay, so what you're going to do is find x to the nearest tenth. Afterwards, you find the perimeter. The way you find the perimeter is just add up all three sides for me. So I'm going to save that one for you guys to do as well. And let's see, I'm only going to do one more of these with you. Let's do, it doesn't really matter. Let's do the playground one. On a playground, the 10-foot ladder to the top of a slide makes an angle of 48 degrees with the ground. So there's my slide. It makes an angle of 48 degrees with the ground, and it's 10 feet long. The slide, oh sorry, that's my ladder, that's my ground. The actual slide makes an angle of 32 degrees with the ground. How long is the slide to the nearest tenth? Okay, well let's start with that. We can use our law of sines. So it's going to be 10 over sine 32 is equal to x over sine 40. Cross multiply. Divide by sine 32. Type it in your calculator. Please make sure your calculator is in degrees, and you end up getting 14 feet. What is the distance from the foot of the ladder to the foot of the slide? Well, that's this distance. And the way we find that is using another law of sines. When you need the angle across from y, that angle will end up being 100 degrees. So it's going to be y over sine 100 equals, and I'm going to use the 10 over sine 32. Cross multiply. Divide by sine 32. And you'll get y is equal to 18.6 feet. We're never going to worry about that one, so just do the problems that we started and you guys have to finish at this point.